In this video I will demonstrate how you can make a geoprocessing model on making a conflict extension polygon representing then the extensions of arm conflict. But first a little theoretical background of it. So we will be using our arm conflict dataset, and this is then dataset which is showing the center point of a conflict. So there has been work being done already of all conflicts event that has been taking place. They have then found a center point which is then situated in the center of a radius which is big enough, with the radius big enough so that all conflict events took place within that circle. Now we thus need to go for a situation where we have one layer with countries. It will be in our case the C-shaped dataset from a certain year, and then having points which are the arm conflict center to this situation here where the conflict extension is represented with a polygon which is then cut by the country boundaries, because by definition an internal arm conflicts ends at the state boundary. And then how to perform this transformation is what I will call one of the most important skills of a GIS expert. He should be able to know how to perform such a transformation. What are the needed steps to go from one situation to another situation? That is to reduce a large problem into its smaller components. So let's go to the practical thing. Let's go to ArcMap, where we have here in the map display launched the internal conflict dataset and the C-shaped dataset from one particular year. We also have our toolbox open, and we have made a tool called conflict tools and made a model called conflict extension. Now this model is now empty, and we will now populate it. We can then open it by actually selecting the edit, and then we will be able to edit the model. Now it's empty here, but we can populate it simply by taking layers from the table of content and drag them into the model builder environment. So there appears as blue ellipses. If not the entire text is appearing, we can resize them as this. And this may appear a little bit here and there, but you can also have the buttons up here which is showing the auto layout, which will make it a little bit more order. So for the moment we don't need to do much about the C-shaped dataset, but we need to do several things with the internal arm conflicts. First of all, this is done from showing all arm conflicts from 1989 up to 2008, and we will here look at only one particular year, and that is for the year 2005. So we are combining then the internal arm conflict with the same year as we have the C-shaped dataset. Now the first thing we need to do is to take a select tool to extract then only those arm conflict sites which took place in 2005. That we will use the select tool for. So we can simply drag the tool also into the model. Now this appears here as white. That means that we have not yet set the parameters for the tool. This we can do by double clicking on it, and by double click on it the same dialog will appear as we have double clicked on it here, but here we set the parameters for the mode we are making. So here as input we will select the internal conflict version, and here you can notice that if the data sets are put into the model, it will appear here with some blue symbology, but if they are from the table of content, they will appear as these tilted squares. So we select the internal arm conflict, and then the output feature class will pop up here. Now this will be pop up automatically since we have set then the environment for this already, and it gives it a name which is not important here because it's a temporary data. But here is something important. We need to set the expression, and we click on the SQL query builder here, and here we will put up the selection that we will extract those conflicts that took place in the year 2005. We click OK, and the expression gets back here, and click OK again, and this is how the model looks. When we set all the parameters, it is being colored with yellow. Now we can actually run the model. This is then the icon which starts to run it. And this goes very quickly, and when it's been run, it will be these gray shaded things here. Now nothing seems to have been happening here, but we can also mark this add to display if we want to have a look at it. So now we added these two, and if we turn off this, we will see that there are not so many conflicts, or there are many conflicts, but much less conflict taking place in one particular year than in the entire period. So we've done that part. The next thing we need to do is that we are going to perform a buffer that as we have here the map projection used a Winkel-Trimple, which is a metric system, and we have the radius values here, which is then representing the extent of the conflict in a circular way. This unit is in kilometers, but the system ArcGIS will here interpret them as if they are meters, so that will be very small circles. So we need to convert these values into meters before we do the buffer, and that's we need to create a new field which we will situate here and calculate the new values which we will later use for the buffer. So we need to add two new tools which are field management tools, which we find here under fields. We need to add a new field, and we need to calculate this new added field. So we can add these two also to our model. First we take the add field, so it asks for an input table, and here we set then the this one it should be, which is the internal conflicts select, and we have to give it the field names. Let's call it radius with underscore meter. Having this as long is okay, so this means long integer, and the rest we can leave as they are. So this is then already colored yellow, so all the parameters is valid. Next thing we do is to set up the calculate field parameters. Double click this input table here. This will be the one, the last output here. So we need to say that we are going to calculate a new value for radius m. This is no data for actually, and we set the expression for how this is going to be calculated. Then we see radius m pops up here, and we just need to set the formula for how it's supposed to be calculated. So we take the radius fields, double click on it so it appears down here, and we need to multiply this with 1000, so we got the radius in kilometers expressed in meters. We click OK here, and we have done the work on calculating the field. This seems to be a little bit messy again, so we can do the auto layout function again, and they will line up nicely. So now we are actually ready to do the buffer tool, so we can add this also to the model. So this is also back here in the analysis tool. Under the proximity we find the buffer, and we drag this into the model as well. We double click it to set its parameters, and we take the last one, the last output, as this input for this tool. As these are intermediate data, we don't need them to be stored. Now here we do not want to buffer all the points in the conflicts in 2005 equally. We want to use the values stored in the field, and we should not use the kilometer, we should use the one in meters, and this we can leave as they are. Actually, there is a little thing here we can do. Since we have the opportunity here to have geodesic distance, we can click this, because some of the conflict extensions indeed are large, and this gives a better result then. And we leave the rest okay. We can take auto layout again, and now we see it's being too large, the model, so by clicking full extent we see all of it. Now let's run the model just to see if it works, and as we hope it will work. So we already run the model so far, so clicking on the run will then start where we ended last time. So then it should start with add field, calculate field, and it takes the buffer. And now still we don't see it, but we need to then add this result also to the field. So we'll see that it has this geodetic distance by the form of the buffer distances here. They are a little bit strange looking, you may say. Now one thing we need to do now next is to clip them towards the state boundary, as these are not supposed to extend the country where they took place, such as here in Colombia. This needs to be cut then towards the state boundary, and then the clipping function will not do the job properly here. We need to use one of the overlay options here, and intersect is the tool which will do the job for us. So we take the intersect into the model as well. And now finally we will be using this sheet-shaped dataset, because now we will intersect the last output here, which is the buffered armed conflict sites with the country boundaries from 2005. So double click on the intersect tool, and we can specify the parameters. So we can take the last output as well as the C-shaped dataset as the two inputs here. We don't bother about the output here, just leave it as the default, because again it will be the temporal output which we do not really care about. We click OK, and the model looks as it is. We can reshape it to look it more ordered. So let's just run this again, and we can put this add to display from the beginning, so it will be added immediately. This takes a little bit longer time because it needs to find all the intersection between polygon layers from the buffered theme with the polygon in the C-shaped dataset. but here it's been finished. And let's see on the result. So here it's been added to the map already. If we turn off the one first there, we see that it's been clipped towards the boundaries. And that's what the intersect is doing. If we have used the union, it will not have been clipped. We will have the full circle here. Now, one more problem we need to have. Here we have that within Colombia there are several polygons actually being resulted from this intersection, and we are only interested in this single polygon, which are inside of Colombia, not Venezuela and the other neighboring resulting small polygons. So we need to select only this polygon here, and since intersect combines not only the geometry but also the attribute, we will see that from the attribute table if we select the one selected here. So here we have an extended attribute table because we have the attribute both from the armed conflict dataset and the C-shape dataset. And here we have an area code somewhere. Yes, this one, it should be maybe conflict underscore S, has the number 100, which is also the country code for Colombia as represented by co-coding. So here we see that these values are equal. If we select one of the other, like this one in Venezuela, we will see that this is the code 101. So this comes from the C-shaped dataset. It comes from this part here, Venezuela, but from the buffered conflict, it still has the 100, which is Colombia, because it's the point here is situated within Colombia. So here we have two non-equal numbers. So then we know actually what we can do to select those polygons which we are interested in. We need to have those which are equal in these two attribute values. So again, we need to do a select. So we take the select tool into the model, we double click on it to set its parameters, and here we have to take the last output and then the expression. So if we remember, it was this conflict underscore S needs to be equal to the country code here. Click OK and OK to set it. And then we will run to see if we were correct. Then it's finished. Let's add it to the display and see if it looks promising. And it does indeed. Now we see that we have removed, or not removed, we have only selected that part of the conflict polygon which took place within Colombia. So we would think we were almost done, but there is one more thing we should do. If we zoom this to the layer, let's look at some other places of the world, like here in South Asia. This is a little bit of messy things. So particularly since we in next exercise we want to use a zonal statistic function to find out how many people are living in conflict polygon, we cannot use overlapping polygon, which we have here. So this is in Burma, Myanmar, if I'm not mistaken, and there are several sites for conflicts there, 1, 2, 3, and they are overlapping here. So if we click on one here, it will pop up with 2 conflict polygons being intersected. So what we need to do here is to collapse these 3 overlapping polygons together in one polygon. And we can do that with a dissolve function, which is a generalization tool, which we found in the data management tool folder under generalization. So here it is, and we drag it into the model. Double click on it to specify it. We take the last output. Do not mind about the output feature class, because again that will be intermediate. And then using the country code will help us then to collapse all those. So this will then, all of these buffered conflict sites will then be dissolved. And we click OK. We can run it to see if it solves our problem. And we need to add this as well to the map view, and we see here that these 3 polygons are now collapsed into one polygon, and that makes us able to use this in a zonal statistics function. So we could be finishing here, but since the conflicts are in a geographical coordinate system, we may want to output this also using geographical coordinate system. So we may then do a map projection back, or project it back to geographical coordinate systems. So this is the project tool. Drag it into our model. We double click it to set its parameter, and we take the last output. And now this will be the final output. So here actually we could be a little bit more clear about what we will name it. So we browse our way to the folder. Here we see a lot of layers coming up here. These are all the green intermediate results. So we call this ARM conflict extensions from 2005, and we could add geographical coordinate systems. Now this is a long name, but let's see if it accepts it. Seems to be doing that. And output coordinate system. Now we want this to be in geographical coordinate system, and we will use the standard ellipsoid or the Earth model for that, the EGS from 1984. Click OK, and it should be done. Now the model looks rather messy, so we can clean it up again. Look at that in full extent, and let's add this to display as well, and we can run the model. Now this won't look very different, because it's although it's in a different projection like the former, it still is the displayed coordinate system which really makes the difference here. Let's zoom to layer here. Now we are almost done, but we can do some cleanup. So since we have set in another video demonstrate how we can store all these intermediate results as a temporary file, we can then actually delete all the intermediate data. And if we do so, you will notice that from the top here that things will disappear again. Then all except the last output remains, and that's what we want to use in further work. So that's the end of the video.